In this video, we'll be going through the steps required to get a minimal installation of the Aspera high-speed transfer server up and running. Aspera is a client-server technology, and that means at a minimum, we need at least one Aspera client and one Aspera server. In this environment, we have a single Windows VM that will run the Aspera client software, and we have a server environment that will run a single Linux VM running the Aspera high-speed transfer server software. To get started with this, we'll head over to the IBM Knowledge Center and have a look at the Aspera documentation. In the Knowledge Center, we can search for Aspera high-speed transfer server. And we can select the latest version, the first option. We're installing the server first, which is on a Linux machine. We can select installation and upgrades and installing HST server. The very first step we can skip because I've already downloaded the software before this video. So you can see here we have the IBM Aspera HSTS installation. We're running Ubuntu, so we've got the Debian release. So from here we can copy the installation command, paste that in. We can remove this $sign, and we can begin the installation. While the installation's running, we can have a look at the documentation at the next step. Actually, a side note, if you are installing this on CentOS or Red Hat, you might get a warning about some dependencies that are required. These actually aren't required, so you can run the installation command with the ignore dependencies. After the installation, we'll be required to entitle the server with either a license or an entitlement. A license is a base64 encoded file, and an entitlement is actually a string. So the difference here is that a license will be bandwidth based. So you'll be able to transfer at X amount of bandwidth. So for example, 1 gigabit per second, and you can transfer at that rate 24 hours a day, 7 days a week. And entitlement is volume based. So if you entitle your server, you might be entitled to 1 terabyte of usage. In that case, you can transfer at unlimited speeds, but you can only transfer up to 1 terabyte of data. So we'll be using the license step here. So we can create the file Aspera license and paste that into the opt-aspera etc directory. So the installation has finished now. We can see that we have the Aspera license here, so we can have a quick look at that. It's just base64. If you ever need to understand a little bit more about your license file, you can run the base64 decode command, and you can actually have a look at the contents inside there for things like the expiration date, the maximum amount of bandwidth that you're entitled to, and some other features of Aspera that we can go through at a later time. So we can move the Aspera license file into the opt-aspera etc directory. And now we'll be able to run the ascp-a command and confirm that our software is licensed. So we can ignore the entitlement because we've used a license. Now we can move on to the next section, configuring the firewall. Now, for this particular environment, I have all the firewalls turned off on both the Windows. You would have noticed a WAN machine in the center that we can use for some WAN emulation later, and also this Linux server here. So there's no firewalls in this environment, but just a quick note on them. By default, Aspera uses SSH for authentication, so we can do that over TCP port 22 if you like. However, you can see here that there's this notice that Aspera strongly recommends running the SSH server on a non-default port. So the standard for that really for Aspera is to run that on TCP port 33001. So in terms of firewall ports, we can open up port TCP 33001, and then the actual data transfer traffic after the authentication has taken place will happen using UDP port 33001. And a quick note on this, and back on the diagram, I've actually made a note down the bottom here, is that if in the case this server was actually a Windows machine, Windows does not allow UDP port reuse. So in that case, if you wanted to do multiple transfers at the same time, you would actually need to open up a port range. So here we've got the fast ports listed, TCP port 33001 and UDP 33001. If that was Windows, we could do something like 33001 to 33010 for 10 concurrent connections. Then we have some other ports here that we will not use for this demo. So it would be unnecessary for this minimal installation, but you could set up inbound and outbound TCP 8080 or 8443 for HTTP and HTTPS fallback. This is in case a client does not have connectivity to the server over UDP port 33001. You would not be using the fast transfer protocol, but you can fall back onto HTTP. We can ignore the others. We're not using a web UI, so we can ignore port 80 and 443 as well. In terms of the client machine, we know that, again, we have to connect into the server on 33001 for both TCP and UDP, and therefore it needs to be outbound of the client machine. Next up, we can look at securing the SSH server. So the first step here would be to edit the SSH config, and we're going to remove the port 22, and we're going to listen on port 33001. So if we come back to our Aspera Linux server, we can edit the config, and if we have a look for port, we can see that at the moment it's listening on port 22, so we can comment that out, and we will add port 33001. Now you can obviously leave port 22 open as well if you want, both 22 and 33001, but we'll just close it. We might need to do some other things. So we can disable non-admin SSH tunneling. We can copy this. We can edit that same file. Here we can just paste it at the very bottom of the file. Here we're turning public key authentication on and password authentication off. So later in this video, I will show you the difference between an SFTP session and a FASP session. So for using the SFTP client that I'll use, I'm going to use a password just because it makes this video a little bit faster. So I'll leave that turned on for the moment. And disabling root login, we can disable that. So it's disabled. And then we can finish by restarting the service. Okay, so next we can begin to set up the user. So we can set up users and groups from the command line, and then set up transfer users from the terminal. Now, before we begin this part, we will actually need to create a user on the Aspera server that will be used by the client to log in. So we can add user ASP1, and we can set a password. Most of the remaining fields can be left blank. Okay. Now, as part of setting up this user, we can actually change the shell to a shell that's provided by Aspera called the ASP shell. That is bin ASP shell. This is for security reasons. The shell is limited to running very specific Aspera commands. So for example, now if I wanted to change user to ASP1, I just wouldn't be able to. I'm still root. We will also want to set up key-based authentication. So there's a few things that we need to do for that. We can make a directory under the new user called .ssh. We're currently root, so we'll want to change the ownership of that. And we want to change the permissions. Okay, we also need to create a new file called authorized keys. And we can do the same. So now we can head back to the documentation. To quickly recap where we are before we continue with the instructions, we've installed the Aspera high-speed transfer server now, and we've also created a user that will be used by the client to log into that server. So now we can continue actually configuring the high-speed transfer server. So In this procedure, number one, we can actually ignore because that's got to do with the HST server web UI, which is deprecated. So we can move on to configuring some global settings. So from here, we don't actually have to use all of these settings because we are doing a minimal install. So we can actually just take the first two lines from this code box and paste them there. As we move down, I'll pick up the necessary config. So we can actually ignore some of these next few lines. You can see here that we can set the user permissions to the user shell to the ASP shell, which we've already done when we created the user. And then finally, we come to configuring user-specific transfer settings. So we can actually take all of these settings here and we can paste that. Now we can remove these hashtags and we can begin to edit these settings. So I might just quickly break these up again. These first two settings, they have to do with the global settings for the Aspera transfer server. So what this is saying here is that any transfer in or transfer out is denied by default. But then later, what we're saying is that for the username, and then you specify the username here, which in this case is ASP1, we will allow transfer in and we will allow transfer out. The next line is the ASP1 doc root. And what this means is we must specify the uppermost directory that this user can access when they log into the system. So in this case, we're going to go back to the transfer server and we're going to create a new directory called Aspera data. And because we're logging in as the ASP1 user, the ASP1 user will need access to that folder. So we can actually change the ownership of that folder to the ASP1 user. Okay, now that we have this directory here, we can change this word doc root to the directory. So now whenever somebody logs in as the ASP1 user using an Aspera client, the uppermost directory that they will have access to is the Aspera data directory. Now this could be a mounted volume. It could also be an object storage bucket as well. There's a specific syntax that's available in the documentation where you can specify object storage here. The bottom two lines actually specify a rate. So in this particular case, it's the target rate. What that means for Aspera, it's the default target rate. And what that means for Aspera is it's if the client has not set its own default target rate, it will get it from the server and it will try and transfer at the default speed that's specified here. So this is specified in kilobits per second. So for example, we could set this to 90,000 and that would be 90 megabits per second. Now we're not too interested actually in the default target rate though. What we want to set is a cap. And what this means is that when the client is transferring to this particular server, the transfer speed cannot exceed 90 megabits per second. So just to point out where I got this word cap from and how I know this particular entry, if you come back to the documentation, you can see underneath this section, you can see this transfer configuration link. Inside transfer configuration, you can see that there's a number of different options and it's probably easier to look at the table. And you can see here, for example, this is the option that we're currently using. So here's a description for it and then what value and then the default for that. So at the moment, we're just going to use the target rate cap. So we can copy these entries and we can now edit them. Okay, and now we can view the config again. And you can see here that we now have the default section filled out. So by default, transfers in will be denied and transfers out will be denied. We also have a new user set up. In this case, it's the ASP1 user. Transfers in are allowed and out are allowed. And then we have the absolute path set to that /Aspera data directory. And you can see here the bandwidth, the target rate here, the cap is set at 90 megabits per second. So that's the server side setup. Now we can actually begin on the client side. Here we have the Windows server. So first we need the Aspera client. Again, you can get the client from downloads.asperasoft.com. You can see here we have Aspera client. I've already downloaded it for Windows. Here it is here. It's a simple click-through installer. So double-click the installer. Select Next. Accept. We can do a typical installation. If this user account doesn't already exist, the installer will make it for you, so you can supply any password that you like. It's just what the services will run as. If you need to run this under a domain user account, you can change that user account to a domain user and select Finish. So this is the Aspera Client GUI. On the left-hand side, we can see the local file system, and on the right-hand side, we can see connections that we can make to remote file systems. So in this particular case, there is just the Aspera demo server, which is there by default. So we want to create a new connection. We can select plus. We can name this Aspera Linux. And we have a DNS entry set up for this, which is Aspera-Linux, which will connect to the server that we've just configured. We want to use the ASP1 user. And we can use a password if we like it first. And then we test connection. And you can see the server was accessed successfully. Now, if I select Browse, we can see that there's no content in there because this is effectively the Aspera data directory. So at the moment, it's empty. If we want to switch to a public key, we can select public key, manage keys, and we can create a new key. So this will be for the ASP1 user. We can leave the passphrase blank. RSA is fine. Click OK. And then we can copy the public key to the clipboard. We can come back to the Linux server and we can add that key to the ASP1 user authorized keys file. Now we can close, and as long as we have that ASP1 key, we can test the connection again, and again it was successful, so we don't have to use a password anymore. We can also see under advanced settings that the SSH port is configured for 33001 and the fast port for 33001. Okay, so now we can select the server and we can select connect. We now have a connection into that Aspera data directory. So if we would like to do a transfer, we can select a file and we can select to upload. We can then select details when this line here is highlighted. And we can see here is the target rate cap, which is at 90 megabits per second. Now, if I killed this transfer off, we can go back to the Aspera server here, and we could update the Aspera configuration directly. So from here, we can actually change this 90 megabits per second to 100 megabits per second. And then we can come back to the client and we can do that transfer again. So just before I do that transfer again, you can see that there is a partial file here. So the details of the partial file reside in this ASPX metadata file. And if we select the same file and upload it again, it will resume from where we left off. So again, we can have a look at the details and you can now see that the target rate is set at a maximum 100 megabits per second. You also have the capability of throttling this manually in the case that you want to reduce the transfer rate, but you can also increase it manually. And then if you tried to exceed the maximum target rate that was specified by the server, you will not be allowed. It'll be brought down back to 100 megabits per second. So that's basically it for a minimal installation of the Aspera high-speed transfer server. We can have a quick look at how the fast protocol operates and how it works with delay and packet loss on the link. So we have some traffic control commands here that can be applied to the WAN emulator in between both the client and the server. And what these will do is they will introduce 100 milliseconds of latency and 0.1% of packet loss. So we can do a transfer using SFTP and then a transfer using Aspera, and we can see the speed differences. So first of all, we can have a look at a ping to the Aspera Linux host. And as you can see, the time is less than 1 millisecond. And there's no packet loss there. So if we apply these two commands to the WAN emulator, we can then check that they've been applied. So you can see that they've now been applied. We can come back to the Windows machine and we can do that ping again. And here you'll see that the time is now 100 milliseconds. Now the WAN emulator isn't an exact replication of a WAN, but it gives us a pretty good idea of what happens on a WAN. So first of all, we can do an Aspera transfer again. So we can remove this file here and we can send it back. There's no caching involved here or anything like that. Aspera doesn't cache data. So we can actually see now that we're getting almost that 100 megabits per second throughput. So Aspera will leave a small gap between its transfer rate and the total capacity of the link so that it doesn't overdrive the network and kick other traffic off. And you can see here that it will finish, and the total time taken was 45 seconds. You can see that in the statistics to the left. Now, if we open up FileZilla, for example, and we make a connection, an SFTP connection to the Aspera Linux host we've got another user account called SFTP user. Remember, we can't use the ASP1 user because it has a restricted shell. So now we can see that we're logged in as the SFTP user to the same machine, Aspera-Linux, and we can copy the same file over. So we can see the transfer rate down the bottom here. So you can see that it's significantly slower. This is using MIBI bytes, so it's approximately 30 megabits per second. So obviously when the WAN is degraded, Aspera will provide significant improvement. And the reason for that is that Aspera can use all the available bandwidth of a link regardless of the network conditions. Whereas when you use TCP-based protocols, they're not able to achieve that. And the biggest differentiator here is that Aspera is currently operating at 100 megabits per second in this particular demo. But if the pipe was, say, 1 gigabit per second, Aspera would again saturate the 1 gigabit per second link. However, this particular transfer here, it's only getting between 30 and 40 megabits per second. If you were to upgrade the link to a gigabit per second and use this FileZilla again, you would still only get that 40 megabits per second. So the total time for that file transfer was 124 seconds in total compared to Aspera running in 45 seconds. So that concludes this video on how to do a minimal installation of Aspera high-speed transfer server.